Greetings, intrepid explorers of obsolete tape formats. In today's video, we will be looking at how I use Photoshop to help digest complicated schematics, talk a little bit about the important role that played for me in trying to understand these things, and then we're going to be going over to a schematic that I haven't really processed at all. It's the playback and record board from a Tascam 488 Mark II. We're going to look at the playback amplifier, and I'm going to show you how I would identify the audio path so that you can use an audio probe or some other kind of tool to identify why a signal isn't getting from A to B. Let us talk then a little bit about what I'm looking at here. Viewers who are British and of a certain age may remember the phrase, "Here's one I made earlier" from Blue Peter. And this is actually quite an old schematic, well, an old treatment of a schematic on my part. And to an extent it's overkill, and to an extent it's marked up in a different way than I would do, were I coming back to this now. But you can see that this page, it's actually got two different boards. You can see that there's already a little bit of greyness baked into the back layer, so I can identify the two circuit boards that are here. This has got the input amplifier PCB assembly, that is it's basically the mixer strips. There's four of them in a 244, and the tape cue. They're showing both of those circuit boards on the same piece of paper, and I've gone above and beyond that. Within this mixer strip, I've sort of color-coded areas to show what they're doing. So I mean, this dark orange area up here, if I just zoom in, that's like the EQ section. The red area is the preamp. Cyan area, that's the input from tape. The green area is the auxiliary send. The fader and the buffering are in this paler yellow, and you can see that I've got arrows to show what direction the signal is flowing from an input to an output. Green and red are used to differentiate between the left and right sides of the signal. I've put some color coding onto the output connector to identify which of the cables is which. So this, white and brown striping here is to indicate that the cable that's coming out of pin 7 there is white with a brown stripe on it. And so it just helps me in a 244, which is a bit of a jumble, a bit of a rat's nest of cabling, to identify what cable is doing what and going where. You're not always going to need to go into this much detail. At one time, I was working on a lot of Tascam 244s, which is why I've made this much effort with these schematics. And at a certain point, when I was learning about this stuff, I found that the materials that were available online, there's a lot of hyper-specific stuff for people who are already good with electronics, and there's a lot of stuff teaching you what Ohm's law is from a maths perspective, but not an awful lot in that middle range where you need to understand something well enough to fix it, but not really any more than that. So for me, figuring out, right, the input's there and the output's there, where do those two places join up? I mean, that taught me a lot about how operational amplifiers work. I mean, I didn't really understand what this was the first time I looked at it. These little triangles are operational amplifiers. And to begin with, it wasn't obvious to me what is the input and what is the output, because there's these 3 points. And in fact, there's going to be 2 of these on a microchip, plus an additional, as well as those 6 points, another 2 inputs. And so I didn't really understand how all of that connected up. I mean, I've watched some videos and read some articles since, but a lot of understanding, all right, okay, these arrows are sort of pointing in the direction of where the signal's going. Where I'm marking there, that's an input and that's the output. So this is almost like an arrow saying signal going this way from left to right across the screen. That helped me to understand what was happening there. I think I'm rambling a bit. What do I need to tell you about operational amplifiers at this point? I'm not going to go into a lot of detail, but we need to know roughly what they're doing, because it will definitely come up when we look at the 488 Mark II schematic. There are other ways that they can be used, but in a Portastudio, these are voltage amplifiers, and really they're microchips that within their guts have got hundreds, if not thousands, of different transistors, capacitors, resistors, etc. But you make an amplifier out of them. It's got very, very high gain, so much high gain that actually it'll just completely saturate. That is, if it's got a 9-volt input, it can create signals that are 9 volts very easily, and therefore it doesn't amplify properly above that point. So we put a loop around them with components. So here you can see that there's a connection coming from the output, which is pin 1 there, through this resistor and being fed back into pin 2, and that controls the gain. But one of the things that we're going to notice is that if you go from an input, you're going to hit a bunch of operational amplifiers. You're going to go through a bunch of electrolytic capacitors of a small value. Here you can see a 10 microfarad 16-volt capacitor. Basically this signal's coming in here, goes through this called a coupling capacitor to this op amp, another coupling capacitor, this op amp. It's going through some resistors as well. Another op amp, coupling capacitor, variable resistor, coupling capacitor, op amp, coupling capacitor, variable resistor, and then output. So the audio path on a signal can be traced by kind of finding where's the input, where's the output, where are the coupling capacitors, where are the op amps, and there's probably going to be some variable resistors or fixed value resistors along the way as well. And we want to find where those points are, because a common thing is, well, let's talk about the problem that I'm having with the 488 Mark II, why I'm bothering to do this, because it is real life. I do have a machine on the bench that I need to fix. And that is the 488 that I've got. I'm not getting playback from channel 8. I've used DuPont wires and my continuity tester to check that the coil in that segment of the magnetic head is intact. The coil's intact, and probably the core of that electromagnet is intact as well. So I can assume that there's nothing wrong with the head. So the next thing for me to check is the playback amplifier. I would assume that there is a signal coming off the head, but it isn't making it out to the mixer so I can hear it, or so that it can be read on the meters, because somewhere in that playback amplifier there is a problem. Maybe there's an operational amplifier that isn't getting power. Maybe there's an operational amplifier that the chip has died. Less likely. One of the most likely things is one of the coupling capacitors that I've just talked about has leaked, or that there is bad solder or bad connection somewhere. So imagining for a moment that it was the playback amplifier. And so this is where I would use like an audio probe. I would send a signal in here, like a 1 kilohertz sine wave, so that there's a beep sound that I can hear through the external amplifier when I touch it with the audio probe. So I would put the probe on this capacitor, and on the top of it I should hear the signal. I should hear beep, and if I don't hear the beep, then I know that already the problem lies somewhere between this capacitor and that input socket. It would be more likely I did hear it here, but maybe when I touched this capacitor up here I didn't hear it, and so that would mean if this point was okay, but this point was dead, the problem needs to be between this capacitor C124 and this capacitor C116. So if I, zoom in a bit, let me see if I can make this cursor a bit bigger. Okay, so I've got a brush, so there should be a big circle, okay? So it's getting in here, it's dead by the time it gets to here, but then there's still 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points where maybe a dead component or bad solder might have cut that signal off. So I can go through those with the audio probe and figure out how far through that procession of points the signal is getting. And that allows me narrow down. So, maybe like I'm getting signal all of these points, but I'm not getting signal of these points. So I suspect that it is that op amp. So I could start to test that op amp, nearby resistors, nearby capacitors and so on, and make sure that they're healthy. Try and find bad components and replace them. That's roughly the process. And of course you could do that without Photoshop, but as a teaching aid, I'll do it for you. If you don't have access to that software, don't know how to use it, then don't worry. What I'm showing you about reading this will still apply. It's just you would look at it figure out where these points are, these coupling capacitors, these op amps, and you'd maybe make a list of the part numbers. So you'd be like, yeah, U102, C114, and so on, and you'd have a list on this piece of paper, and then you'd find them on the board with your audio probe and check that that signal's coming through, and make a note where it stopped, then go back to the schematic, find that component, see what's near it, and then you can start debugging specific components by, you know, pulling them out of circuit and testing them with your multimeter, that kind of thing. So here in my PDF viewing software, I've got the service manual for the 488 Mark II open. This one's available for free download on my blog, as are many schematics. And I've navigated to page 53, and here I have the schematic diagram for the R/P PCB. That's the record playback printed circuit board. I mean, I guess any Portastudio or multi-track cassette recorder is going to have multiple printed circuit boards on it. It varies from unit to unit how complex those are. Some of them have more than half a dozen printed circuit boards, some of them only have two. This is a more complicated one, but it's good because the record playback is all on one board, so you're not kind of trying to think your way past a whole bunch of other functionality all on one board. So we can see that this is on page 53 of our PDF and also on page 54. Whoever's published this PDF, this isn't my scan. They've distributed that image across 2 pages. So then what I do is I find it in the folder and I say open with Adobe Photoshop. There would be other software that you could do this with. I'm going to gloss over the details of how exactly I'm doing this in Photoshop because it's an electronics tutorial, not a Photoshop tutorial, but I'm selecting those 2 pages, and if I go OK, and I should be able to open the 2 Photoshop files. So what I'll do is I'll make the one on the left, I'll make the canvas bigger, about twice the size. And I'm going to duplicate, in fact I'll save this now, so I'll call it schematic RP board. Okay. Duplicate this layer, so it should be, I've got both halves on the same schematic here. Now, if you're a Photoshop user, maybe this makes sense to you. If you're not, then maybe it doesn't. Basically what I'm doing here is making sure that these are kind of like parallel. Like sometimes the whole scan will be squint, and so when you superimpose one half on the other, then it doesn't work. It looks like we've got like a little missing part here. We can probably figure out what's going on all right. Anyway, I'm just going to merge those layers now, call that the background. This is a common sort of visual device if you're in a position where you've got identical sections of a circuit or very close. In this case, we've actually got 8 playback amplifiers. So it shows one of them in detail, and then it shows 7 sort of blank areas with a little notation about how the parts numbers differ. So like, here, these operational amplifiers are, for instance, U102B and U102A. But for channel 2, they would be labelled U201 and 203. For playback amplifier 3, they would be labelled U301 and to 303. So all of these parts numbers, C103, R107, C1, U1, Q1, that first number in the part number denotes that it is related to channel 1 of the playback amplifier, whereas that 1 will be replaced with a 2 for channel 2, 3 for channel 3. But anyway, this thing on the left, that is the tape input. That represents the coil inside the tape head. So that is our input. So what I'm going to do is I'm going to make a separate layer. I'll call it channel 1 audio path. Pick a colour that's highly visible, so I'll just go for green. Brush, is that a bit the right size? So I can start going, right, my input's coming in here. I'll tell you what, because we've got a missing bit here, and because this is a pretty complicated circuit, you know, I probably should have chosen a simpler model. I'm only going to go as far as this low pass filter for the purposes of this video. Normally what I would do is I would find an output, And you know, a general convention for these kind of things is that inputs and outputs tend to be on the left and the right of the schematic. If they're trying to save a lot of space on the same piece of paper, then it's not always going to flow from left to right as we would read in the Western world. Sometimes the signal will flow from right to left, but it's much, much less common for it to go up and down. You're normally looking, first of all, left to right, but possibly in the opposite direction. Like I've seen schematics where the record and the playback amplifiers are on the same sheet, so the playback signal goes from left to right across the schematic, but the record signal goes from right to left. So this is why I'm looking over here on the right hand side for my output. What we've got, tape out, record signal, or, you know, I would probably have to do a bit more investigating here to figure out what my outputs are here. This is complicated because the biased and record amplifier, of which there are only 4, because you could only record 4 tracks on a 488 Mark II. There's something weird going on with the routing that I don't fully understand because I haven't studied the schematic much. On a simpler unit, like a 4-track unit where you would probably see outputs where it says going to mixer channel 1, going to mixer channel 2, or something to that effect. And so we could work from both directions. But turns out for this tutorial, or whatever this is, I'm just going to start at the input and get to that point. Okay, so what's this dotted line with a K here? K prefixes are usually relays. Although on a reel-to-reel machine, we would often see that the reproduction head and the record head are 2 separate heads on Tascam Portastudios and, you know, their equivalents made by Yamaha, Fostex, whoever. The record and playback is handled by the same head, but the erase head is separate. That means you have to have some sort of switching system in there to change whether the record and playback head is receiving information from the tape or transmitting information to the tape. Sometimes that's done with relays, sometimes it's done with transistors. On this one it looks like it's done with a relay. So we can see the physical switches. If I make my brush a bit bigger, there's the switch and there's the switch, but that's associated with this part number here, K101. And so, you know, through these diodes, that'll be going off to signals that are being sent from a microcontroller that responds to what the user is pressing buttons, you know, depending whether you're in playback mode, record mode, then that's changing these switches inside this relay so that this record playback head is either recording or playing. But we can assume, for the purpose of following the playback signal, that this switch would be closed, and so this signal would be coming out of here through the switch and going up here. And you can see that there's a, you know, basically there's a kind of voltage divider here. And one end's going to ground. You can usually tell that these thicker lines, all of these things are joining into one rail here. That's going to be ground. So we don't need to, it's definitely not going left. And like I was saying earlier in the video, these op-amps are almost like signposting on a path. So I know that the signal is definitely going in this direction. I mean, I'm pointing like this, but my image will be reversed on the screen presumably, but from the left of the schematic to the right. Gets to this junction. Okay, capacitor to ground, what's that doing? It's doing some kind of peripheral engineering level thing that we don't need to worry about. We can think about the one that's going horizontally, right? So it's going through this resistor, and here we come to our first coupling capacitor. So it's coming through that coupling capacitor. I mean, I think this is the bias trap here, but again, we don't really need to worry about that. So it's going into the positive input of this operational amplifier. See, I mean, all these other components here, that's to do with setting the gain, really. The audio path is coming out of the tip of the triangle and it's going to this junction here. Now this junction is all feeding back into the feedback loop and everything, so I think it's going through here, past this resistor. There's a little voltage divider here into the input of this operational amplifier, and it's coming out the tip there. Now obviously that signal is going to like a variable resistor here. You know, this is, you know, this will be one of your trim pots. In fact, this is going to be all off to the part of the screen that you can't see because of my face, isn't it? This and this, they are bookending these 2 op-amps, and I guess that the reason that it's 2 op-amps there is that one of these is associated with this trim pot, so perhaps that's the level trim for that playback amplifier. And then it's coming out of that coupling capacitor. these two resistors between them are setting a level that's going into this low pass filter. So this, in fact, this is probably the playback EQ here. That's what's happening there. So we go through that resistor, coming out the other side of that, and then, whoops, down to this variable resistor. And from there, it's probably going off wherever it's going. Ah, right. So, in contradiction to what I told you earlier about, inputs and outputs are usually in the left and right. Are they, fuck? Not in this schematic anyway. They usually are in the right and left, but there's an output here. This is roughly what we're looking for. It's coming out of the, I'll make the cursor bigger again. It's coming out of this record playback head, assuming that that relay is closed properly. And the relay being fucked is like, that's a possibility for why I'm not getting any sound. And it's going through this resistor, through this coupling capacitor, through this op amp. Really this pair of resistors together, it's a voltage divider, so that's like biasing the input of this second operational amplifier. It's coming out of that operational amplifier through this coupling capacitor. And then it's going through this, I'm assuming LPF stands for low pass filter, so that's all built onto a chip. I know it's a chip because the part number U103 has a U prefix. The U prefix is used for integrated circuits and Tascam schematics. I mean, probably for a lot of schematics as well. It's coming down to this variable resistor and then along to the output. So with my audio probe, I can test, is it getting out of the relay? If so, is it getting past that capacitor? If so, is it getting out of that op amp? If so, is it getting past this op amp? If so, is it getting past this electrolytic capacitor? If so, is it coming out of this chip with the low pass filter in it? If so, is it getting past this variable resistor? And in fact, I could do a faster thing where I'm like, make sure that it's at least getting into this relay to make sure that there isn't a problem with the connecting cables coming from the head into the system. But then test this resistor, because if it's okay there, then I already know that I shouldn't be troubleshooting this board. I need to see what's happening about how it comes out of this board and into the rest of the system. But let's say this one's fine and this one isn't, then I could pick a point maybe halfway along there. So maybe I test on the output of this operational amplifier, and if the signal's okay there, then I know it must be one of these points to the right where there's a fault. But if it isn't okay there, then I know it must be basically that capacitor or the relay that's at fault. So you can kind of like cut things in half when you're troubleshooting. There's an algorithm for that in computer programming. Can't remember the name of it, but it's a way to kind of like more efficiently sort through a task. There probably will be some footage up on Tinterweb from me when I actually apply this to the 488 Mark II, some sort of repair report. But I hope that gives you a rough idea of how you should be finding the audio path in a schematic. Because when you get a schematic, it's got a lot of stuff on it. This has got, that looks like that's the bias circuit on it, probably got dBx noise reduction on it. There's some sort of bus thing happening where 8 channels are getting filtered down into 4 sub-channels because this unit only records on 4 channels at once. The circuit for power is in there, so there's a lot of information that you don't need to concern yourself if you're just like looking for an audio signal that's disappeared. I mean, how many components are on there? I don't know, guess hundreds. Anyway, like at least 200, maybe like 500 components. But actually, when it comes down to it, if we've got one dead channel, let's say it's channel 1, there's only 1, 2, 3, 4, 5, 6, maybe at most 8, maybe as few as 6 places that we're going to test in order to find out roughly what's wrong before we can start sensibly replacing things and hoping for a solution to our problems. If you're finding this more kind of like technical, electronics focused side of what I'm publishing helpful, I'm doing quite a lot of detailed stuff like this for patrons and Patreon at the moment. I've been doing a kind of half-hour video like once a month. At the time of making this, it's just turned May in 2022. I've already got 3 of them up, and I'm going to be doing shooting another one later today. So check that out. Thanks for watching. Hope to see you again soon.